to I2, which is the one coming here, and into I1. You can see. So at the end of the day, you find out that I is equal to what? I1 plus I2. That's because the current has been splitted into two. So whenever the current is split into two, this shows that this is parallel connection. Now, let's look at the properties of parallel arrangement. Like I said before, different current flows through this resistor, and then the total current will now be I1 plus I2. 2. Each resistor has the same voltage. Yes, the voltage here, that is the source. By the time it gets here, we are taking that the voltage across R1 is the same thing as the voltage across R2. Okay? And the next property is that the total resistance is always less than the individual resistance. So by formula you can see that RT, which is the total resistance in this formula here, is equal to R1 R2 over R1 plus R2. Alright? Plus R2. So that's it. The total resistance is always lesser than the individual resistance, unlike the series where the total resistance is greater than the individual resistance. And lastly, the property of parallel connection is that the total voltage is always the same, like I mentioned earlier. The total voltage is always the same with the individual voltage. That's why Vt is equal to V1 and is equal to V2. Alright, so here ends the lesson. Thank you and have a good day. Bye.